Assalamualaikum and hi. Our group BMFI 34 will explain about our project which is Smart Material Handling Device Palm Oil for Sime Darby Plantation, Merlimau. First, let me introduce myself. My name is Nur Aida Batrisha binti Azman. I will explain about Chapter 1 Executive Summary. Our project problem statement is Sime Darby Plantation face challenges with the current material handling device used for pickup up palm oil for a truck. Based on the problem statement, this project aims to design a smart material handling device that is user-friendly and efficient. For the design process, team members conducted interviews with workers to improve the device. The data collected then used to inform the design of new devices. Next, I will go to Chapter 2 Project Team Organization. Organization structure provides a visual representation of the roles and reporting lines, aiding in understanding the organization overall framework. So the figure here shows our team organization structure. Next, communication plan. Communication plan is a strategy that outlines how communication will be managed throughout the process. So the figure here is our communication plan with the tools or platform to know project status update, in-person meeting, user research, and data analysis. Next is project timeline. Project timeline provides a visual representation of the project's planned progression, enabling team members to track progress and ensure timely completion of deliverables. The figure shows our project timeline start with product development until preparation IDP final report. Next is Chapter 3, which is specific design problems. So here is some specific design problem need to be addressed when developing our product. Number 1 is compatibility with existing infrastructure. The device should be designed in a way that be easily integrated with the existing infrastructure, such as lorry. Number 2 is durability. The device will be operating in harsh environment that can use even in bad weather. Number 3 is ergonomic and usability. The device must be user-friendly and easy to operate. Number 4 is maintenance. The device must be easy to maintain with components that can be easily replaced or repaired.
For our vision, we need to create a smart material handling device that helps improving the safety and health of palm oil workers. Objectives to maximize efficiency and safety among labor for the entire manufacturing floor, including picking, sorting, and loading systems. For the output, create a good material handling system that can reduce the physical stress involved in workers dealing with heavy palm oil and repetitive works. For the target markets, we aims the Sime Darby plantation workers, palm oil plantation managers, and industries that involved in palm oil plantation. For the constraints, limited time to create and improve the product, limited budget for development and marketing, less technical knowledge in product development. For the risk, there is difficulty in designing a functional and portable device, failure to achieve the product's user-friendly, low-cost, and ergonomics criteria, and lastly, failure to attract customers from traditional method when picking up the material. Next is the data collection. For the first step is definition and planning. We identify the research question, user needs, target users, and expected outcomes. Next is collect the data. Next is analyze the data. We are extracting insights and identify patterns and trends. And then we interpret the results, interpreting to draw conclusions and insight about the user needs. And lastly, we share the findings. For the next slide is basic information of the respondents. For the first table, it shows the gender of respondents. Next table is the respondents' age. According to the survey's operators' ages, there are 2 respondents who are between the ages of 21 and 30. 6 respondents who are between the ages of 31 and 40, and 2 respondents who are between the ages of 41 and 50. From the data collected, here are few recommendations to improve the material handling of lifting fresh fruit bunches in the palm oil industry. First is increase automation. Is use adjustable lifting equipment. Lastly is optimize ergonomics.
Hi, I'm Dio. Now I'm going to talk about the product specification. First of all, This diagram shows the user needs requirements. From the user need requirements, we know that what customer wants and what they need. So we now list out the 3 primary targets that we are going to plan for. First of all, the comfort height positions. From the survey form, we know that most of the customers face back pain when using the existing device. Therefore, we need to design a device that is suitable for their height positions. And then it's a high performance. We need to ensure the efficiency of the work reach the demands, which means that it won't affect the efficiency of the work when we're using the device. And therefore, it also can help to improve the efficiency. And next is most of the workers are refused to have training before their work. Therefore, the device should be user-friendly. And this is the house of quality. From the house of quality, we know that which part of our product need to be improved, which is mean time between failure, operating method, and also the cost of materials. Besides that, from the house of quality, we also list our 6 most important voice of customer that we are going to translate into the technical specification. First of all is the mean time between failure. The company requires us to design a device that have a minimal error when we're using it. Therefore, we plan that the mean time between failures should not exceed 3 times a year. And then it's the operating method. The operating method should be user-friendly and straightforward to learn. So we use the pedal to control the height of the lot for the lot supporter. And then for the cost of materials, the cost of material must remain within the budgets and should not exceed it, which is from 300 ringgit to 1000 ringgit. For the comfort height positions, we need to ensure that the height is ergonomic to the users. Therefore, we adjust the height to 50 cm before extending, and after extending it will become 200 cm, which is suitable to the worker's height. Furthermore, for the mean time to repair, it is crucial for the repair mean time to be short, which can help to prevent the work delay and improve the efficiency of the work. Therefore, the mean time to repair should not exceed 1 time every 3 years. Lastly is the ease of operation. The device is designed with intuitive control, user-friendly interface, and ergonomic features to ensure the platform workers can easily understand it and use it. Therefore, the startup, backup, and the recovery buttons are incorporated into the smart handling device for ease of operation, allowing operator to easily initiate it.
Design conceptualization. So let us start with product benchmarking. The first competitor for our product, which is smart material handling device, is a running mini grabber of all palm fruit. The second competitor is loose fruit collecting machine, and the third one is in a manual way, which is using a sickle. So initially there were 10 designs that have been sketched by our team members. Each team member have sketched 2 designs. So based on all the designs, we have selected only 5, the best 5. So here are the designs for 5. So in order to select the best design, we have used morphological chart, and then we also used concept screening and scoring, which is Topsys. So here are the rank for all the designs, and we have made the decision of design 1 is the best alternative, which has the highest performance score. So this is the picture of the selected design. This is the prototype that have been sketched using CATIA software, and here is the bill of materials we have done in a table form, which has part name, part number per unit, total quantity required, and also cost unit. So this is a storyboard that which depicts our material handling device. So here are the storyboards that have been done by all the team members. So thank you.
The figure shows the prototype of smart material handling device. Workers in the palm oil industry move the smart material handling device to a place where they need to carry the palm oil. The palm oil will be loaded into the device and lifted to the levels of the truck. To identify the severity of the postural analysis will be carried out by ruler methods. The final score are displayed by a color code in CATIA. Final score for our prototype when pushing and pulling smart material handling device is 2. Index 1 or 2 indicates that the posture is acceptable if not maintained or repeated for a long period. Indicate the lifting load is safe for the operator. Next is about the push-pull analysis when dealing with smart material handling device. Based on the figure, the time consumption used is 2,700 seconds is equally to 45 minutes. Besides that, the distance of push or pull of the smart material handling device is 2,100 mm is equal to 2.1 meter. Other than that, the population sample is 50% because the subject of this experiment are 5 workers out of 10 workers. Hence, the population sample is half of the overall worker. Referring to the results of the maximum acceptable sustained force for pushing activities is 333.465 newtons, while the result for pulling activities is 318.317 newtons. According to the results, the worker used around 333 newtons to push the device or used 380 newtons to pull the smart handling device along the activity performed. The sustained force is the gross effort needed when the workers do their work during their working hours. This investigation shows that the starting force required to push or pull the smart material handling device can influence by the working activity, the push-pull activity distance, and the weight of the smart material handling device and pump oil.
And now I will show you the fabrication plan. This is the material selection we use to fabricate our product, and there are total around 10 materials will be used to proceed for our product. For the manufacturing process, there will be 4 processes be taken to manufacture our product, which is arc welding, milling, drilling, and sawing. And this is the work breakdown structure. The work breakdown structure is organized into 4 levels. The device is primarily constructed using 3 main parts: the base, support, and top. The base is composed of 2 items, an angle bar and wheel. And then for the support, a section consists of 2 parts, a hydraulic pump and a scissor legs. Lastly, the third part is the top part. The top part was making with a little box.
I will explain about Chapter 10, Cost Analysis. First, we construct the cost breakdown structure. Cost breakdown structure provides a comprehensive view of the various cost components involved, including the material cost that calculate the cost for wheels, body, and other parts of the product. Next, development cost, which is involved design, prototyping, cutting tools, and testing. So here is the table calculation, which is involved the material cost for smart material handling device production, including the part of wheels, body, and others part. And here is the other calculation, which are the development cost, utility cost, maintenance cost, and labor cost. So we managed to get the total cost. So here is the break-even analysis for our project. Break-even analysis calculates the level of sales or production needed to cover all costs, both fixed and variable. So based on calculation, the break-even sales is 6,000 ringgit with the 2 units product needed to cover all the costs.
Strategy to a sustainable product design. DFE guidelines have been created based on 5 aspects. The first aspect is material extraction. So these are the DFE guidelines for material extraction. The reasons to create this is to minimize the environmental impact, to reduce waste, to protect soil quality, and also to prevent deforestation. And the next one will be production. So these are the guidelines. The reasons are mostly related to process of the production, like efficient cutting and shaping, strong and stable weldings, efficient fabrication, and proper installation of hydraulic cylinders. The next one is transport, distribution, and packaging. These are the DFE guidelines have been created, and the reasons are mostly to ensure it is advantageous, secure, and helpful transport, distribution, and packaging processes. The next one is use. So these are the guidelines. The guidelines are created mostly for the reasons for risk management and also safety. So to prevent accidents, to reduce the risk of damage. And the next one will be end of life design for disassembly and design. These are the guidelines created, and most of the reasons are regarding to extend the possible lifetime of parts and components, and also to decrease the need of new product and raw materials. So
Besides, I would like to explain about project challenge and mitigation strategy. First, distance and transportation difficulty. This case study is far from Newton's. The teams was performing online meeting for the latest update and interview sessions. However, the physical duties has also been conducted when collecting data. Next is about technical difficulties. To mitigate these risks, the team conducted through research and testings of the technologies and materials involved in the project. Besides, we tried to get assistance from the SV to help resolve the technical issue. Third list is about budget difficulties. To respond to this issue, the team need to plan our budgets accurately and remain the projects within the budget. Next is about the communication difficulty. The teams is formed from the different casts, hence we use the online platforms as the meeting methods, and it can be done anyways and anytimes. Fifthly is about inadequate skills. An effective project integration plan will address the project requirements as well as the resource needed to complete it. Last but not least is about inadequate risk assessments. Due to the large number of variables and potential outcomes, project rarely turns out exactly as expected. Hence, a project risk assessment system facilitates the identifications and mitigations of various risk types. It is crucial to have a backup plan in place.